Oh, well, thank you for joining us on this support session. This is a small session on geometric series. We've had a question come in to do with a geometric series, and so let's have a look at that answer. Let's just close some of these windows. I think, let's make room for this if we can. Okay. Now here we have a question, and it says the adult population of a town is 25,000 at the end of year one. A model predicts that the adult population of the town will increase by 3% each year, forming a geometric sequence. Now, let's just make a note here. If there's a geometric sequence, it's like the first term we'll call it A. The second term of a geometric series is A times R. The third term is AR cubed. The fourth term, get this right, AR squared. And the fourth term is AR to the power of 3. Now this goes, there is a general rule for the nth term, which is A times R to the power of n minus 1. So this question says that our first term at the end of year one is, say, 25,000. That's our population of the town. And they've mentioned that if we have a 3% increase, this means that R is 100% plus 3%, which means 103%. R is 1.03. Show that the predicted adult population at the end of year two is 25,750. So we simply need the second term, which is AR to the power of 1, which is 25,000 for A, and R is 1.03. So 25,000 on your calculator times 1.03, and that is 25,750. All right. Now we could have shown that using a calculator like this: 25,000 multiplied by 1.03 equals 25,750. Good. Now, part 2, write down the common ratio of the geometric sequence. So thereafter, what is the common ratio? And the common ratio is the second term divided by the first term, or we've got this symbol here. So it's 25,750. We've already actually worked out this, but I'm just showing you a working. If they want to see a formula, you can just divide any two consecutive terms, the second term divided by the term, or a term divided by the term preceding it. Now the model predicts that year N will be the first year in which the adult population of the town exceeds 40,000. Now at some point in time, we don't know when, I'll put N, the population is greater than 40,000. So let's say that we want to know what N value will make it equal to 40,000. So let our 40,000 equal A times R to the power of, and R is, we already know, R is 1.03. 1.03 to the power of n minus 1. So that's this formula here. Take the 25,000 across, 40,000 divided by 25,000. That is 1.03 to the power of n minus 1. 40,000 divided by 25,000, we can just 40,000 divided by 25,000. I wonder if that's, no. 40,000 divided by 25,000 equals 1.6 equals 1.03 to the power of n minus 1. Here we use log. This is index form, so the log to base of 1.03 of 1.6 equals n minus 1. We can use the change of base rule here. That is the log of 1.6 divided by the log of 1.03 will equal n minus 1. We'll do that on our calculator. I don't have there is a way, isn't there? There's view scientific. Oh, that's cool. All right. So the log 1.6 log, we can use ln. We don't. Yeah, we can use this to base 10 divided by 1.03 log equals, and that will be 15.9006. So let's just say 15.9, add 1 and we get 16.9. Now, at 16.9 years, we get to exactly 40,000, but it's the answer is which year is it? And it will be year 17. So when n is 17, we will get a population greater than 40,000. You can try it by doing this. Use 17 equals AR to the power of 16, 25,000 times 1.03 to the power of 16 equals 25,000 times 1.03 to the power of n minus 1, which is 16, and we would get 40,117.66. Was that right? 44,117, was that the value we got? I can't remember. But we're dealing, or is it 40,000? Let me just check that. 25,000 times 1.03 to the power of 16. 40,000, yeah. Okay. That's just 40,117, about 0.7. And that is the 17th year. So which year? It's year 17. All right, so here is a small example of geometric sequence. You need to use the formulas for the nth term. This question, there is another formula here for r. There is no formula here for sum unless the question continues. I don't know if there's a part D. Okay, so I hope this has helped one small step of your revision. And until I either see you next or talk to you next, stay happy.